Aloha class, here we go. Last section in chapter 5, and then let's get ready to dominate that test. Is section 5.9ers, transforming polynomial functions to apply. So we are going to graph now cubic functions. Okay, remember we did this for quadratics, and it's really the same thing. It's just a little RST. All right, and if you're able to do RST, you dominate this stuff. So let's get after it right off the bat. All right, we're going to do example 1. We're just going to do 2 of these bad boys, believe it or not, and then you should have a good grasp of what's going on. Y equals 2 times the quantity x minus 3. We're going to cube it, right, because we're dealing with a cubic function now, okay, plus 4. All right, and then we're going to graph that. Now, able to graph that, remember, we're always going to deal with what we call a parent function. This dude's parent function right here, and we'll do it in blue. This guy's parent function is y equal x to the third. We kind of go bare bones. Bare bones. We take out the 2, the 3, and the 4. Everything else that would result in a little RST transformation, we take it out. And we start with y equals x to the third. Now, we need to know what y equals x to the third looks like. Now, remember, whenever we do that, we deal with a table of values. Okay? And this is probably the longest one we're going to do here because we're going to need the most points for a cubic function. Okay? And so you always want to use points that should be easy for you to get. Now, if you remember for a quadratic, the vertex was important. A cubic kind of has a vertex, and we'll talk about that as we graph it, okay? And it happens at 0, 0. Why is it 0, 0? Well, because if I plug a 0 in for this x up here, 0 to the third is 0. Okay, another good point to choose would be 1. 1 cubed is 1. Another good one would be 2. But 2 to the third this time is hachi, or 8. All right, and then for cubics, it's important to know what's happening to the left of the vertex and to the right of the vertex. To the right of the vertex would be 1, 1, 2, and 8. To the left of that vertex would be -1. And then what's -1 to the third? Well, that's -1, Mr. T, because you have 3 negatives. 3 negatives keeps it a negative. And then what if I had a -2 and I did -2 in here for x and I raised that to the third power? Same thing. -2 times -2 times -2 would be a negative hachi. All right. And so we need to know what that graph looks like. So let's go ahead and graph those points. And remember, that's important. It's kind of like a vertex. What do you mean, Mr. T? I'll show you. 2, 8, I'll say it's up there. And then we got -1, 1, which would be there. And then 2, -8, which is down. It's a graph that looks like this. Okay? And there is your important point you want to know. We don't really call it a vertex because a vertex would be the lowest or the highest point, but it's where we turn. Okay? It's where we do that. All right? So it's going to be very important that you know that. Now, that's the parent function that you want to be very, very familiar with. We are going to do that on every problem we deal with. That's a cubic polynomial. Okay? So now how do we graph this bad boy? Well, believe it or not, you know. It's just a little R, S, and T. So we ask ourselves if there is a reflection. Do you guys remember from the previous chapter? There is no vertical reflection. I'll do all the notes for this first one, okay? Vertical reflection. We always say over the x-axis, right? Over the x-axis. Okay, there's no vertical reflection. Why is there no vertical reflection at home? Because there's no negative out in front. Remember, everything out in front or outside deals with the function vertically. Okay, there's no negative on the outside, so there's no vertical reflection. Next, is there a stretch or shrink? And there is, because there's a 2 on the outside. It's 2 times. Remember, that affects it vertically, and it would stretch or shrink. Since the number is bigger than 1, we say it's a vertical stretch. So we say there's a vertical stretch by a factor of 2. Okay, it's 2 times. All right, last translation. Do we remember inside what that means? What does that 3? That 3 is inside, so if it's inside, it affects it horizontally. And since it's a 3, remember, we kind of do the opposite. So we would say 3 units to the right? That affects it horizontally. That 4 is on the outside, and it's a +4, so that'd be 4 units. Do we remember? Up. Okay, and then what do we have to do to get this problem? Well, believe it or not, we've done all of this before, right? But I'm going to use this table of values this time. All right, so for the reflection, what's my new table of values look like? Same exact. There was no reflection. Right, class? There was no reflection, so I end up with the same thing. All right, let's go stretch and shrink. Stretch and shrink. Well, it said vertically by 2. Remember, vertically means it's up and down. It means it's the y. Anything outside, remember, influences the y. Okay, so we're going to take all of my y's and we're going to multiply them by 2, by a factor of 2. So that means all of your x's stay the same. And then it's going to be negative 16, negative 2, 0, 2, 16. Okay, remember what's important here? That guy and that guy, because that's where it goes. Remember that? Okay. And then last is we have our translation. Okay, x comma y. What's the translation? What says 3 to the right? So what would that mean I do to all of the x's? Right, horizontally is my x's and it's 3 to the right, so that means 3 units to the right, so that'd be negative 2 plus 3, negative 1 plus 3, 0 plus 3, 1 plus 3, and 2 plus 3. Okay, 1, 2, 3, 4, 5. And then 4 up. Okay, negative 16, that'd be negative 12 if I added 4 to that guy. That'd be a positive 2, that'd be 4, that'd be 6, and that'd be 20. What's important again? Spling, spling, spling. So important. And you always want to graph that first. Now I'm done, though. Let's graph this bad boy. And 3 comma 4. 1, 2, 3. 1, 2, 3, 4. Hopefully you have some graph paper at home. It's gonna right there. It's important. And I'm even gonna put 3 comma 4 on that 1 point because it's so important. All right, 2 negative 1 comma negative 12. All right, I'm just gonna estimate, be like way down there. Okay, 2 comma 2 would be right there. And then 4 comma 6 would be about there. And then 5 comma 20 would be there. So let's get, whoops. Whoops, I thought that was a point. Right, kind of changes shape right there. Sorry, you guys at home, bear with that. Okay, but it kind of wiggles. Wiggle, wiggle, wiggle. Right there at 3 comma 4 is where it goes. Okay, it changes a little bit. Okay, and actually that where it changes there has a lot to do with slopes and AP Calc, which maybe you'll take someday with me. Let's go. All right, here we go. We're going to do one more. And then we have one different type of problem to finish the day off. All right, here we go. Erase, erase, erase. Okay, there it goes. It's thinking. Oh, I was going to hit pause, but we can just get it. All right, here we go. Y equals. Let's go y equals. Let's go negative 3. X plus 1. Let's raise it to the third, which makes it a cubic, right? And then let's just go with minus 2. All right. Now, how do we graph this guy? Well, we have to use the parent function. Y equals x to the third. So you better remember what this guy looks like. I'm going to use negative 2, negative 8, negative 1, 0, 0, 1, 1, and 2, 8. And then remember, what does it look like? Right? It looks like that bad boy right there. Important to make sure you pay attention to. All right, and then all I have to do is do a little RST, and then the problem would basically be done. Okay, RST, is there a vertical reflection? Yes, there is a vertical reflection in this problem. Why is this a vertical reflection? Over the x-axis. Why is there a vertical reflection? Because of that negative out in front. So that means what the heck would that look like? If I flipped it about that line, what would it look like? All right, so my answer better look like that red one. Whenever you have a vertical reflection, it's always important to make sure you understand what your final result should look like. And that's what it should look like. Okay, is there a stretch or shrink? That's a 3. Remember, we take the negative out. 3 is bigger than 1, so we say there's a vertical stretch. Vertical stretch by a factor of 3. Okay, and then we have that plus 1 on the inside and the minus 2 on the outside. The plus 1 is on the inside. Remember, we always kind of do the opposite of the inside. The inside means horizontally, which would mean left or right. So that would mean 1 unit to the left, and then mean 2 units down, right? Okay, let's go ahead and get our points. All right, so we do a little R. There was a reflection. And if there's a reflection, it's vertically, so it affects the Y. So what do we do with all of the Y's? Okay, the X's are all going to stay the same. But what's happened to the Y's? They're going to multiply by a negative. It kind of flip-flops. Oh, it flip-flops? Is that why this? Flip-flop? Sure is. Okay, so it's going to look like that red one there. And then there's a stretch. There's a stretch by 3. So that means we multiply all of the Y's by 3. Oh, snap, 24. I'm going to need a lot of graph paper, right? You're multiplying here. Okay. Ooh, 8. What the heck is 8? Somebody catch me at home there. If you did, you are monies. 24. Okay, and then last we just have our translation, which would mean 1 to the left. 1 to the left would be my x's, which would be negative 2 minus 1, which is negative 3. Negative 1 minus 1, negative 2, 0 minus 1, 1 minus 1, 2 minus 1. All right, and then 2 down. 2 down would be 22, would be 1, which would be -2, which would be -5, and it would be, oops, that should be a negative, be -26. All right, let's graph that bad boy as best we can, and it should look like this one right here. All right, it's going to be stretched though, right? Super stretched, right? So we go, ooh, most important, most important, most important. That's where it goes, meow, right? So we should always graph that first to understand that that guy is the most important. -1 comma -2. So remember, that's where it goes, meow. All right, so -322, what the what? That's way up there. Okay. And then we have -2 comma 1, -2 comma 1, 0. So it goes, okay. And then we got 0 comma -5, which would be about right there. And then 1 comma -26. So it's going to go, whoops. Whoa. Okay, sorry, it's kind of hard there. But that's where it has that wiggle, right? Wiggles. Wiggle. Okay? And that's it. That is graphing cubics. It doesn't get any more tougher than that, you guys, until you get to a little pre-calc days. All right? Make sure you always hit pause, or, the beautiful thing about flipping this classroom and watching those bad boys at home is that you guys can rewatch the video and hit pause and all that stuff. All right, now, anything in math, we always want to go forward and then we want to go backwards. All right, so how the heck, if they give me this graph right here, how can I get the original equation, right? So we're just going to go entirely backwards. Now, hopefully, if you're looking at this, you're like, there's a reflection, right? Because they're went opposite. All right, so here we go. So now going backwards. Now, able to go backwards, you need to know the formal equation for a cubic. And here's your formal standard form equation for a cubic. It's y equals a x minus h cubed plus k. Kind of like if you remember when we did the vertex form for a quadratic. And remember, what was important for the vertex form was the vertex. And I told you guys that's the important thing, where you get the wiggle, okay, for a cubic. So that means this guy is your h and your k. So whenever you're doing these problems and you want to come up with the original problem, you fill in your h and your k first. Now your h is a +3, so that minus is going to stay minus. Remember, we always kind of do the opposite, okay? And then it's going to be cubed, and then k is -2 plus a -2, right? Okay, so now you're actually done if you can find out what a is. All right, so I think it's helpful to write in your HK, circle that bad boy, box that bad boy, rectangle that bad boy, and then you find a. Well, how do I find a? Well, you use this guy or this guy, the other point, okay? And the other point you're going to use as your xy. You don't have to use both, you just use one. I'm going to use that one right there, okay? So that means that for a y, I'm going to plug in a 6, and for a, right, or the whole point here is I got to find a, all right? Parentheses, and for the x, I'm going to plug in the 1. And guess what? If I do the work, it's going to tell me what a is. Well, what do I mean by do the work? All right, we have to simplify first. Please excuse my dear Aunt Sally means parentheses. So you go 6 equals a. That's -2 to the third minus 2. Parentheses done. Exponents, what's -2 to the third power? -2 to the third power is -8. And I always put that in front when there's a variable. Okay, because it's -8 times a, it'd be -8a. Okay, now look at it. Nice and easy, Japanese. I just got to solve for a, and what do I get? I get a equals -1, which totally makes sense. So what is the equation here? So now you go back to this rectangular equation, and your equation is always y equals, what is your a? -1. -1, and you always put your vertex in there. And if you were to put this bad boy into your calculator, you would get that. Sweet! We're just doing one of those. What I would encourage you to do right now, do this problem over again, and instead of using this point, use this one. And you're going to get the same exact answer. And make sure you do it, okay? Because you're going to get more efficient and really good at this stuff. Aloha, that's it with Chapter 5, we're going to review like class, and then we're going to dominate this test, all right? And remember, go back and look at any of the other videos that you need to look. Make sure you're practicing your homework, and make sure you're doing the review. Alohas.